Day 41, last day of the week. Number 1, Eric and Pam receiving money to buy a car. Eric has $750 saved and an additional $30 a week. So this is what's changing, is that every week is changing, so that's going to be our variable, which means the 30, because that's going with the variable, is the slope. And this is the constant because it doesn't change how much he started with. Constant. Okay, so that's Eric. Pam has 1,200 saved. So that's her constant. And an additional $20 a week. So $20 a week. Week is, we don't know how many weeks, so that's still X, our variable, and 20 is our slope. How many weeks will it take Eric and Pam to have the same amount? So I want to know when they're the same. So if I want to write the expression for Eric's amount, I'm going to write it down here. So his is 750 plus 30x. And I want to know when is that equal to Pam's, which is 1,200 plus 20x. Okay, so I want to know when they're the same. So now this is just a multi-step equation. I can do that. I want to get the variable to one side, so I need to get rid of one of these. It's easier to get rid of the smaller one, so I don't have a negative. So if it's positive 20, I'm going to subtract 20x from both sides. So this will cancel out. Okay. So the only thing left on this side is 1,200. And 750 is the same, that didn't change. And 30x minus 20x is just 10x, and it's positive. So now we're down to 2 steps. You always do what's with the variable last. So to get rid of a positive 750, you would have to subtract 750 from both sides. And this cancels out, so I'm left with 10x equals. And then if you always want to check your work, because that way it's accurate, minus 750. Which will give me 450. And then in order to get the x by itself, you need to divide by 10 since this is multiplying. So if anything you do to one side, you do to the other. So it'll give you x equals some number, and that is the answer to number 1. That's how many weeks that they'll be the same. Number 2, the graph shows the number of new houses built from 1970 to 2000. No, it's hard to read. This is 1970 down here and 2000s over here. The mayor used the graph to claim the number built increased at a constant rate. So constant rate means that it should be linear. And it definitely looks linear. So let's read what the options are. A, it is valid because the graph shows a constant rate of change. Well, it looks like that. But let's just make sure and read the other ones. B, it is valid because 30 years is long enough to evaluate the increase. If that's all they're interested in, then sure. But let's keep going. C, it is not valid because the scale on the vertical axis is inappropriate. Okay, vertical axis is your y. So let's see what the scale is. 0, 5, 10, 15, 20, 25, 30, 35. Well, that's the same difference. So the scale keeps going up by the same amount. So I'm not worried about that. It is not valid because the scale on the horizontal axis is inappropriate. So horizontal axis is your x. So it's hard to read. Let's see, 1970 to 1980, that's 10 years. 1980 to 1990 is 10 years. 1990, 92, 94, 97. Then suddenly it's 2 years apart. So because these are 10 years apart, and then all of these are 2 years apart, it's not the same spaces, so that it would alter what this line looks like. So it would have to be D.